Okay, so in this first part, we're going to calculate the speed and the distance. So we need our two equations. Anyone remember the equation for the speed one when we're talking about free fall? V equals velocity. And what do we have to do to get the velocity? We have to take gravitational acceleration and multiply by the time. And our second equation is the one to figure out the distances. This is the one that looked a little bit more complicated. Its distance equals 1/2 gravity multiplied by the time squared. So what we're going to do right now is we're going to do the first one together as a practice, and then I'm going to give you a couple of minutes to actually finish for the other times. Actually, I'm going to ask somebody in the room if they'd like us to do it for the second, the third, the fourth, or the fifth second. Kaltuma, should we do it for 2 seconds, 3 seconds, 4 seconds, or 5 seconds? 2? Okay, we're going to do it for the 2 seconds. So when we're figuring out the speed at 2 seconds, that means we take our gravitational acceleration on Earth, 10 meters per second squared, and multiply by 2. 2 times 10 is 20. If you need a calculator, feel free to use it. And that would give us meters per second, because that's velocity. So in this box, you would just have to type in 20. You do not need to put the units because they're already up here at the top. That's one nice thing about organizing in a data table, is if you put the units in the heading, you don't have to write them anywhere else. Okay? So now we need to figure out the distance traveled. I'll do that one in red. So we're going to use this equation. So I'm not going to rewrite it. Let's just do a little arrowing. So our distance is going to equal 1/2 times 10 again, because we're still assuming this rock is being dropped on the planet Earth, multiplied by 2 seconds. Let's see if I can squeeze this in here. Squared. And as I said yesterday, I like to work from kind of the outside in with this to make sure I only square the time. So 2 squared is 4. 4 times 10 is 40. And then I have to take half of 40, which is, ooh, look at that, 20. Again, use a calculator if you need to. So the distance will be 20. This one is interesting. It's the only place where the velocity and the distance traveled will match if you're dropped from rest. It will be at the 2 second time. The rest of them are not going to be the same. Okay? So what I'm going to do now is ask you to do the calculations for the 3rd second, the 4th second, and the 5th second, and fill in the table. You do not necessarily have to show the work because we've done it here. You can just take out your calculators and change these to the times that you want to and do the math. So let's say 12:20 on the Google Meet clock. You got 4 minutes. Do it. Includes everybody in the room. Do it! Devin? What? Should I do the calculations for the 3rd, 4th, and 5th second? Have you done them yet? Okay, doing them? Okay. And then just type yours in. Remember to type it right into your table.
Can't type it to a PDF.
Oh, open the doc. Open the other one. I opened the PDF back up. Sorry. I didn't explain that. Yeah, if you open the optional PDF, you won't be able to type in it, but those with Chromebooks, I think you can write on it. But but you might want to go back and open the doc. I did it as a PDF just in case.
Make a copy. Like you're sharing it, so we can't edit.
Oh,
We gotta make a copy.
shoot. Okay. Hang on. I'll fix that little issue because I'm.
Well, if you do that, then everybody can.
No, I know what to do. Hang on. I know what I did wrong. This one. Okay, now it won't let me. There we go. Or just write it on paper. I didn't mean to do it that way. And let's try it this way. And my computer's being really slow. Very slow. Yeah, because I think I just shared it with you guys as a view, didn't I? Ah, that was bad of me. Wow, we're like spinning. All right, so just do the calculations and we'll fill it in together. I apologize for that mistake on my part. I forgot I was going to do the force a copy. Okay, so it looks like we got under a minute here. Two seconds. And there we go. Okay, so which column do you want to fill in first, the speed or the distance? In the room, you get to tell me. Speed or the distance first? Speed. So what's the speed at 3 seconds? 30. All you got to do is take the 10. I think I'm going to go back to a darker color. 10 times 3. And then for 4 seconds, it would be 40. And for 5 seconds, it would be 50. Okay. So the speeds take gravity times time. That's as simple as you can get with that. Now the distance is going to be a little bit more work because you have to square the time. So I'm just going to put in what you should have gotten. For the 3rd second, it should be at 45 meters. Yes, 45 meters. 9 times 10. Yep. So you would put 3 in here. So you change this to 3. So 3 times 3 is 9. 9 times 10 is 90. And then you take half of that. So you get 45. The next one is 80. And the final one should be 125. So notice how where the distance is different in the increments it goes up. So speed goes up by 10 as you're falling, but distance, there's no set. You really can't look at the pattern on that because it goes from 20 to 45 to 80 to 125. And the deal is it's that squaring factor that messes you up. All right, so now we have a few questions to answer. At which of the following times is the acceleration the greatest? So which times, is the acceleration the greatest? This is a trick question. They're all the same. Because gravity pulls on all objects at the same rate. So on Earth, it's 10 meters per second squared. On the moon, 1.67 meters per second squared. Okay? At which of the listed times is the speed the greatest? Well, what time was the speed the greatest? On our chart, it'd be the 5 seconds. Why? Because that was the longest time it was in the air. So the speed keeps increasing the longer the time you are in the air. Now here's an interesting one, number 4. If the falling time of a free falling object is doubled, the distance fallen increases by a factor of, So let's go back to our data table and let's look at what happens with our distance. So if we take the second, this one, if you double that, you go to 4. So we're looking at this distance and this distance. How many times bigger is 80 than 20? So if you took 80 and divided by 20, what would you get? Anyone got a calculator to do it? 80 divided by 20. 4. So the distance increased by a factor of 4. Notice when you double the time, you increase this by a factor of 4, and that has to do with the squaring part. Just a little trivia information. We are not going to look at the back page. It's basically a repeat of what we just did on the front page. So I've decided not to include that one. We're going to do that differently. Okay?